All right, Brandon Clayton, the Algebra Guy here. Today, our discussion will talk about solving any word problem. Any word problem. I want to give you a strategy, a template by which you can use to solve any problem. So actually, let me just jump into it. I'll show you what I mean. So let's approach any word problems with a positive attitude, use a problem solving strategy for word problems, and solve number problems. So this positive attitude thing seems kind of weird because we're talking about math and just solving numbers, right? But it's actually been researched that having a great attitude affects your performance. So that's important. But I'm going to give you a strategy on how you can go about every problem. So let's start with this problem in order to understand what I mean. Pete bought a shirt on sale for $18, which is half the original price. What was the original price? Well, if he bought it for 18, which was half the original, you can probably figure out in your head what that is, but that's not the point. The point is, how will we think through this for more difficult problems so we have some strategy by which we can answer this? So I'm going to give you, I think it's 6 steps that you can, maybe 7, but we'll review those here in a second. The first step is read the problem. This is going to entail understanding all the words that's in there. I was so frustrated when I first started reading because I would have to look up so many words. But after looking up so many words, I didn't have to anymore, obviously, because it made sense. I found that word. So make sure you understand the vocabulary. You may need to read the problem 2 or more times. Some students don't want to do that. But man, even as an adult, as someone who spent hours, hundreds of hours doing math, I still read the problem multiple times because I still tend to misread if I go too quickly. So if there's words you don't understand, look them up in a dictionary or the internet. So in this case, what would we do? In this problem, do you understand what is being discussed? Do you understand every word? So Peter bought a shirt on sale for $18, which is 1/2 the original price. Now, if we didn't understand, what mistake could we have made? We could have easily said, which is actually where my mind went, I thought $9 because I thought half of 18 is easy. And that's what a lot of students are going to think. They're going to quickly glean over that problem. They're going to see 1/2, they're going to see 18, they're going to think, easy, 9. But reread the problem, make sure. He bought the shirt on sale for 18. That was half of the original. Oh, so hopefully that changes it for you once you can reread and get that context. The second step is we're going to identify what we're looking for. Oh, absolutely important. If you don't know what you're looking for, it's easy to just start working. Like I see an 18, I see half, I'm just going to start doing things. So what do we want to know? We want to know the original price here. So make sure you understand what it is that we're looking for. It's hard to find something if you're not sure what it is. Read the problem again and look for words that tell you what you're looking for. So in this problem, the words, what was the original price of the shirt, tell you what we are looking for, which is the original price of the shirt. Lastly, name what you're looking for. So let's give it a name. Choose some variable that represents that quantity. You can use any letter as a variable, but it may help to choose one that helps you remember what it represents. So in this case, we're going to use P since we're talking about price. So let P equal the original price of the shirt. And you may see me go ahead and write out that whole thing, and that X equals or P is going to equal the original. And notice we didn't just say P equals shirt. That's a common mistake too. Why would that be a problem? Because we don't know what about the shirt. P represents what? The color of the shirt, the number of shirts, the weight of the shirt, the size of the shirt. What about the shirt? That's really can be confusing. So when you're getting down into a lot of steps, you just want to be able to look up here and say, oh, the price of the shirt is what we're looking for. And you don't want to put price because it could be price of anything. Now let's translate into equations. Let's translate this problem into an equation. It may help first to restate the problem in one sentence with all the important information, then translate it into the equation. This is probably, I don't want to say the most, but man, it's extremely important part because now we can actually put it into mathematical language where we can do something with this information. So we see 18 is 1/2 of the original price. Well, let's write it out, right? So you see here, let me go back because that was some good information. So we see 18 is 1/2 of is my multiplication and P represents the original price. What a beautiful way to translate it. Now it's ready to be solved, which is our next step. solve the equation using good algebra techniques. Even if you know the right answer, using algebra will be better to prepare yourself solving problems that don't have obvious answers. So I encourage you in the following problems I'm going to work today. You're going to see them, some of them be pretty easy, you can do in your head, but that's not the point. The point is to produce a strategy and habit that you're used to working so that when you come across a problem that you don't really understand, you have that strategy available. So write the equation. 18 is 1/2 of p. So we just kind of simplify what we just said. Now let's solve for p. To do that, we multiply both sides by 2. That gets that 1/2 to just 1p, and this side goes to 36. So now we solved it. And pretty much we'll stop there normally. But here's where the average are separated from the best. So the top students always have some way of checking their answer and making sure it makes sense. And you don't necessarily have to do all the calculations again. You could. That'd be another level to make sure you're the best. But you can just kind of think to yourself, does this problem in general make sense? I have to do this all the time because we all are human and make mistakes. So we found that p equals 36, which means the original price was $36. Does $36 make sense? Well, yeah, because 18 is half of 36. So that makes sense. We don't have to do much more there. And lastly, answer the question. So why do I say answer the question with a complete sentence? Because it would have been easy to simply stop and say 36. And that last little piece will sometimes cause students to miss the problem. 36 what? 36 shirts, 36 inches, 36 miles, 36 minutes. No, $36 was the original price of the shirt. So make sure you go the full way. Don't do all that work and stop just short of the finish line. Check your answer and make sure you're answering what the question asks you to answer. So if he were actually working this on paper, you may not have done all this work in that fashion, but it would kind of look like this. Notice we have all the steps here. He read the problem. He named what he was looking for. He identified what he was looking for one, and then he named it. And then he set it up, translated. He got the sentence that we wanted to translate, and then translated it, and then checked it, and gave the answer that they were looking for. Answered the question. All right, so 7 steps is what I have. And I know it's a kind of a lot, and I try to think of some kind of acronym or something we could use, but rent, sky didn't really ring a bell. So I think we're just going to have to do a number of those before it kind of embeds in us. But to help us, guess what I came up with? Pictures. Yay! Because we all love pictures. So here's read for obvious reason. Identify as a magnifying glass. Name is a name badge. Translate is this thing here trying to translate A into a different character. Solving with a pencil, checking, answering, and answer the question. This arrow is saying don't forget to answer your question with a little smiley face. Let's try it. Let's try a few of these. I got 5 or 6 of these and see how we do. Yash brought apples and bananas to a picnic. The number of apples was 3 more than twice the number of bananas. Yash brought 11 apples to the picnic. How many bananas did he bring? Blah, 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 blah. We're going to definitely have to reread that. But let's check off. Did we read it? Yes. Do we understand all the words? Yes. Do we understand what they're saying? Let's read it again. The number of apples, he brought apples and bananas to a picnic. The number of apples was 3 more. So he has more apples, 3 more than twice the number of bananas. Okay. Yeah, Yash brought 11 apples to the picnic. How many bananas did he bring? All right, so let's identify what we're looking for. We want to know how many bananas. That's what we're looking for. How many bananas did he bring? So we're going to name it by saying, let's represent the number of bananas. Bananas. Okay, yeah. So let's let that represent with B. Actually, you know what? I better not use B. Why? Because it looks too much like a 6. So I'm going to use N in bananas. Now let's try to write a sentence that we can translate from these words into something algebraic. So let's look up here. The number of apples was 3 more than twice the number of bananas. The apples, so let's say we got apples. I'm gonna number of apples. I'm gonna come up with a variable for apples so I can represent that too. Number of apples was 3 more than what? Twice the bananas. 3 more than twice our bananas. So Yash brought 11 apples to the picnic. Okay, great. So we have this translated now. Apples was 3 more than twice the bananas, and now we know what the bananas were. They're 11. So knowing that, we can figure out how many bananas he brought. So let's actually solve this. Subtract 3. 11 minus 3 gives us 9. 9, 10, no, that's 8. 8. So we divide by 2, and B is going to equal 4. All right, so we translated it, we solved it. Let's check our answer. 4 bananas. Does that make sense? Let's see. We have 11 apples to the picnic, 4 bananas. Does it make sense that he had more apples? Yeah, because the number of apples was 3 more than twice. So yeah, it's going to be more. So we checked it. Now we got to put it back into answer the question. How many bananas did he bring? We don't want to leave it like this. We want to say he brought 4 bananas. Bananas. So I would normally say he brought, if I want to do the whole thing. He brought 4 bananas. Okay. Next one. Nagai's car insurance premium increased $60, which was 88% of the original cost. What was the original cost of the premium? All right, so we read the problem. His car insurance, let's read it again, make sure we understand. The car insurance premium increased by $60. This, which was 8% of the original cost. What's the original? So what are we looking for? We want to know the original cost of the premium because it increased by 60, and that 60 was 8%. So let's name what we're looking for. We want the original, let me say original cost. Original cost. I'm gonna let that represent, I'll say P for price. Yeah, I'll just use that. I could use X or Y, but we use P for price. All right, so I named it, and now I'm gonna write it into a sentence. So this is probably the toughest part. If you can get through that, it makes it so much easier. So let's look at it. The car insurance premium increased by $60, which was, so this was telling me there's an equal sign here. So $60 is 8% of, that's times some original cost. Hey, look at that. So we can work with this. Now I don't want a percent there. I'm actually going to translate that percent into 8% is the same thing as 8 over 100, which is equal to 0.08. So I'm going to translate that into 0.08. Okay, thank you for that reminder. 0.08. There we go. All right, now I'm going to solve it. So we did the translate, and then we're going to go ahead and solve this here. We got to get P by itself. So we're going to divide both sides by 0.08. Divide that by 0.08. Those cancel out. Now I end up with P equals 60 divided by 0.08. What is 60 divided by 0.08? My calculator is going to tell me 60 divided by 0.08. 750. All right, so 750. Are we done? No, because we check our answers. That makes sense. It increased by $60. It can be that makes sense. It can be $750 because it went up. If it went up 60, it means it originally was $690. So that makes sense. Let's answer it completely though. So to answer this completely, it needs a $sign. So we're going to say the original cost of the premium was $750. So now we answered it completely. You want to try this one? I will pause it and see if you can go through those steps. All right, we read the problem. The difference of a number and 6 is 13. So the difference, I read the problem, check. and identify what we're looking for. Find that number. So let's let X represent some number, the number we're looking for. The difference of a number and 6. Difference of a number. So difference is subtraction. So a number so subtraction and 6 is equals 13. All right, so now it looks a lot easier. I named it, I translated it. Now let's solve it. I'm going to add 6 on both sides. X equals 19. Solved it, checked it. The difference of a number is 6 as 13. Yep, looking at this equation, that makes a lot of sense because 19 minus 6 is 13. And find the number. That's the number. I can't answer that question any better. All right, similar problem. The sum of twice a number in 7 is 15. Find the number. So I'm going to let that number represent X. Call it the number. The sum of a number. So some number, the sum, we're dealing with plus, right? The sum of a number, this, and 7 is 15. So now I'm going to solve it. See, I'm going straight to my solving here because these go by pretty quickly. You don't have to slow down too much once you get into that routine. So X equals 8. Yep, that makes sense. 8 plus 7 is 15. I checked it, and that's all we got. All right, one number is 5 more than another. The sum of the numbers is 21. Find the numbers. So these aren't ones that you can just think of right at the top of your head. You actually do have to set it up. So we read the problem. I understand all the words. Let's think about what we're looking for. Fine, I got 2 numbers, it looks like. So let's let the first number equal 1. First number, and one number is 5 more than the other. So we have one number. Let me do it this way. So I have one number, because this is a lot better to do it this way, I learned. One number is X, and another number is X plus 5. So instead of writing X and Y, it's a lot easier to do it this way, because it's that same number and 5 more. So one number is 5. One number is 5 more than the other. So I got some number and another number that's 5 more than that number. The sum of the numbers is 21. The sum of these numbers, X and X plus 5, is 21. So I've identified the naming right here. I didn't say X and Y, I just made one X, the original, and something plus 5. Then I translated it. Now I'm going to solve it. X and X give me 2X plus 5 equals 21. I want the X by itself. First thing I'm going to do is subtract 5 on both sides. I'm left with 2X equals, what is that, 15? No, 16. 16. Now we divide by 2. X equals 8. So the sum of the numbers is 21. Find those numbers. I got 1 is 8. So that's one answer. What's the other number going to be? Well, X plus 5. So let's add 5 to that 8. 8 plus 5. And that's going to be 13. So those two numbers are 8 and 13. Now, you could have missed this by thinking you're finding one number. Like, oh, X equals 8. But because we went back and double checked what they're asking for, it was easy for us to say find the numbers 8 and 13. All right, pause it here and try this yourself. The sum of two numbers is negative 14. Sum of two numbers is negative 14. So one number is 4 less than the other. Find the number. So one number is X, and one number is 4 less than the other. So we got a number and it's 4 less. But we also know that the sum of those numbers is negative 14. So X plus X minus 4 is, is negative 14. And by the way, it's common for problems to put the numbers in words because they're harder to see. You want to take your time and read it because I was like, where is that number? And there it is. You know, here's our 4, here's our negative 14. So don't miss those. So we read it, we identify what we're looking for here. We identify we're looking for the numbers and we named them. We translated this word problem into an equation and now we're going to solve it. X and x is 2x minus 4 equals 14. I'm going to add 4 on both sides because I do my adding and subtracting first when I'm solving for a variable. That gives me 2x. This goes to 0. And this is 18 divided by 2 on both sides leaves me 9. Aww. And there it is, ladies and gentlemen. X equals 9. But we're not done. I almost said we're done. But it says find the numbers. So I know that we're solving this and I was trying to check it, but I'm like, wait a minute, there's 2 numbers. There's this entity here and there's this one here. Those are 2 numbers. This one's 9. This one's 9 minus 4. So we're going to have another number that is equal to 9 minus 4, which is 5. So our answers are 9 and 5. All right. I'm going to change colors just for the fun of it here. One number is 10 more than twice another. One number is 10 more than twice a number. Their sum is 1. Find the numbers. One number right here, that's a number, is 10 more than twice another. So we got some number here, but there's another number that has that number, but it's 10 more plus 10 than twice another. 10 more than twice. So it's twice that number plus 10. 10 more than twice. Let me make sure I said that. Yeah, this is 10 more than twice. All right, so their sum is 1. And even just to see me pausing there to think, because that's the reading part, I have to think, what are they saying? Is that what they're, okay, yeah, that's what they're saying. I've identified the question. They want me to find the numbers. I've named them. And this is our name and we're giving them. We don't have to say x and y. We're going to say this is x and this is 2x plus 10. And let's translate that into an equation. So we know that their sum is 1. Sum is going to tell us plus. So this is x plus 2x plus 10. All right, now we're going to solve. 2x and x gives us 3x. Oh, I forgot to say equals 1. I was like, where's my equation? Their sum is 1. 3x plus 10 equals 1. And I'm going to subtract 10. 3x equals negative 9. Divide by 3. X equals negative 3. So one of our answers is negative 3. So this right here is going to be our negative 3. This is going to be 2 times negative 3 plus 10. It's negative 6 plus 10, which is positive 4. So we have 2 answers, negative 3 and 4. All right, the sum of 2 consecutive integers is 47. So this is kind of interesting. You got to understand kind of a new technique here when they talk about consecutive. Consecutive means they're in order, like 1 is 2, 3, 4, they're consecutive. So the sum of 2 consecutive integers. So you have one that is n, let's call it n, and then you have another that's after that. So some number plus 1. Why? Because you got, like, say for instance our 2 numbers are 4 and 5. There's 4, then 4 plus 1 more, or 6 and 6 plus 1 more, and 7 and 7 plus 1 more. So that's why we said n plus 1 more. So those are the 2 integers. And we know the sum of those 2 integers is 47. So we got n. So we read it, understood it, identify what we're looking for. We're looking for those 2 numbers. We named them with n and n plus 1. And now we're translating it into an equation right now. The sum of those plus n plus 1 is my equal sign 47. So what two numbers are consecutive numbers of each other and equal 47? So let's solve it. N plus n is 2n plus 1 equals 47. I'm going to subtract 1. That gives us 2n equals 46. Divided by 2, n equals 23. All right, so my two numbers are going to be, this was going to be 23. 23. And obviously this is going to be 23 plus 1, so it's 24. So my two numbers are 23 and 24. We can check our answers by just asking ourselves, do these two numbers add up to 47? And I'm hoping they do. 2 plus 2 is 4. 23, 20. I think you already know they do. 24, that's 7, and that's 4. So, yep, they do add up to 47, and they are consecutive. Find three consecutive integers whose sum is 42. All right, so we got one that's n. So we want three consecutive. That's our question. And let's name it. One is n, another is n plus 1, and another is n plus 2, because it's going to be 2 away, right? Because instead of 3, 4, 5, so this is, let's say that was n, then this would be plus 1 for the 4, and for the 5, we need to add 2 to the 3. So we need, that's how we should set it up. So we know that the sum of all these is equal to 42. So I named them, and let's set it up as an equation. Now, n plus 1. I'm going to put parentheses just to remember that it's representing a number. And n plus 2 is 42. All right, so solving this, we got n plus n, which is 3n. 1 plus 2, which is 2, equals 42. Subtract 2 on both sides. And I get 3n equals 40. Oh, no, that's not going to come out evenly. So n plus 1, n plus 2. Oh, that's because I didn't do that right. Thank you. 1 and 2 is supposed to be 3. And by the way, this is a good lesson. So you see what I had to do? And this is why you want to show work as well. And it's okay that I missed it, and I'm not a math teacher, because we're just people. That's what happens. But I want to show you what I did when that happens. I said, hold on, something doesn't make sense. So I have to go backwards in each step, starting from the beginning actually, and say, okay, did I do that first one? N, that's 3n, 1 plus 2. So you really have to go through, and this is save yourself from going up to the teacher every time and asking them, did I do this? Did I do this right? But check yourself before you wreck yourself. I had to do that. All right, so subtract 3. 3n equals 39, and now this is going to be coming out more evenly. Divide by 3 and get n equals 13. All right, so if n is 13, that means I have one number that's 13, another number that's 14, and another number that's 15. If these all add up to equal 42, I know I'm good. So let's try it. 13 plus 14 plus 15. Oh, it does. Yay. All right. And we're done. Approach word problems with a positive attitude. I did. I was encouraging. I was smiling. It was great. Use a problem-solving strategy for word problems. We did. There was a 7-step strategy. Do you remember it all? Let's see. We got, first is read. The next is identify what we're looking for with the little magnifying glass. After we identify, we name it. So we have the little name badge. And once we name it, we translate it. So we translate what we're looking for. Okay. So when we translate it, after we translate it, we solved it, we checked it, and then we put it back into the answer. All right, that's it. Thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.